See, we've had a couple of folks arrive into the meeting. We're going to give it a minute or two here, and we'll get started. So we appreciate your patience. Well, welcome to this version of Hawk Talk by Illinois Institute of Technology's Alumni Association. As we get started, would ask that all the participants today, please, if you could, whether you're on your phone or you are using the VoIP option with GoToMeeting, would ask that you mute yourself, and we will be able to unmute at the end to take questions. I have the ability to mute you as well, and I will mute everyone but our presenter, but I wanted to let you know that I will be doing that. Our topic today is Big Data, Truths and Myths, a Practitioner's Perspective. Our presenter today is Brian Ippolito, and Brian is a graduate from IIT in 1992 in aerospace engineering. He serves as president and CEO of Orbits Technology, and he's been in that role since 2006. Under his leadership, Orbits has established itself as a leader in delivering somatic applications and cloud analytics to the Department of Defense and select Fortune 500 companies. With that, I'll let Brian get us started, and Again, you can use the chat function, and I will unmute at the end for questions. Brian.
Good afternoon. So thanks for joining the presentation. I'm going to walk through this. If at any time anyone has questions. So the objective of this discussion is really to share, from our perspective, lessons learned associated with big data. Our first big data program was probably back in 2007, and we've seen a lot of patterns repeat themselves. Most of our clients are clients who are big enterprises, so our clients deal with petabytes of data a day, integrating 600 databases, integrating 20 global data centers, folks who have really large enterprises. And so it doesn't really matter as much as the domain as the size of the enterprise. So we've collected a fair share of lessons learned, and the objective of today is to just kind of share some of those lessons learned to sort out what I call some of the truths and the myths associated with big data. So our perspective, and this isn't necessarily a sales pitch about our company, but I think it's important to understand the perspective. We provide products and services, big data products and services that do a variety of functions. Most notably is our ability to mediate and create virtual clouds within large data centers. Because what happens is clients all want to move everything to one data lake, and then they realize, for many reasons, some of which we'll talk about here, that idea is not cost effective. And then we build kind of our forte and our claim to fame, our text analytics, and we do cross-document correlation across 150, 200 million documents, so we can detect plagiarism and similarity and things like that. But when you deploy things globally, and for anybody who's ever dealt with Hadoop and big data environments, one of the things you learn is they're incredibly temperamental, and there's not a lot of documented knowledge from a practitioner perspective. And so when you deploy things globally halfway around the world, we can't deploy a whole technical team of Hadoop developers or semantic web developers. So we have to make sure that we follow a very disciplined process, and that we follow and incorporate as much previous knowledge from successes and failures as we can. So with that, I'll start with my disclaimer, and my disclaimer is the following when we discuss this topic. We are not a retail software provider, so I'm not someone who provides mobile applications, games, Microsoft Word. We are really an industrial software provider. We're not what you think of as a classic IT company. Corporate IT shops are what we consider to be vocational IT, and that's not necessarily intended to be derogatory. It's meant to say that our developers are really computer science majors, computer engineers. They're not folks who would sustain corporate IT infrastructures. It's really the professional side of technology, information technology services. And our clients are truly big companies. So smaller companies don't have the same requirements as our clients, but our clients are large enterprises, to include Department of Defense and Fortune 50. Our experience and our perspective is really shaped by early adopters. And so I think that's really significant because we see adoption cycles with big data. And so our experience is driven by those folks who decided to move a large enterprise into a Hadoop environment. And typically they go through learning cycles. And so what we try to do with our clients is shorten that learning cycle based on previous lessons learned. So starting with that, and some of these images might be a little bit dated, but my point here is Hadoop's been around for a long time. So Hadoop for us is synonymous with big data, and most people use big data analytics every single day, right? Users who clicked A also bought B. So that's a weblog transactional analytic recording clicks, and eBay uses Hadoop infrastructure. Those are very simple transactional analytics. It's the same with the product analysis. These are all things driven by clicks, right? So the real question for big data analytics practitioners is to say, are you advocating big data because you're trying to add a nice feature, making something user-friendly, or are you using this to drive your top line revenue, or are you doing this as a cost avoidance or cost savings? And so you have to kind of widen the spectrum on your view of big data, because it's all really driven by the business case. And that's typically with our clients, they're trying to decide where do they fall. And when we show them some very simple examples, and we could go on for hours about big data examples that most people don't even know are out there, the truth is, it is, from a Hadoop perspective, it has been out there for a very long time. The adoption cycle has skyrocketed. So, what are some of the big data truths and myths? In preparation for the presentation, I have to tell you, I probably could have populated 200 articles, because everybody, apparently, if you're a publicist, the answer is get it somewhere between 5 and 10 truths and myths. And a lot of them contradict themselves. And so just reading through them, you'll see some folks say, well, big data is not really about a massive data volume. It's not about the data. It's about the analytics. It's synonymous with Hadoop and unstructured data. My favorite is NoSQL, means not SQL. You need all the data. You can get rid of all the data. It leads to certainty. It's immature. It's mature. It's temporary. It's going to be here forever. And the funny part is, when I listed I pulled out from myths and truths, and I put them on the left-hand side, you can't tell the difference because it's really all shaped by somebody's personal experience implementing in an ecosystem. And so what what I hope to share with you today is just our experience implementing this for clients who have realized, no kidding, monetized value in implementing Hadoop big data systems. So big data really starts with expectations. And one of the things that I do regularly is sit with senior members, and they ask me all the time about the business case. And so what should we do? What should we expect? And typically big data starts with big expectations. And the reality is, when I talk to other CEOs and senior executives, nobody's doing this for fun. Now maybe the IT shop is, they want to learn, and maybe they want to make more money on the top line, but generally speaking, most of our clients are trying to do one of two things. They're trying to create a revenue base, a new stream of revenue, or they're trying to significantly enhance their capabilities by doing something that cannot be done in any other architecture. So we don't see a lot of situations where we're pursuing big data for productivity reasons, where we want our folks to be more informed, we want them to be better. A lot of the myths that are out there, a lot of them say, well, we're doing this because we'll be a data-driven world and people will make better decisions. The truth is, none of our clients believe that. Our clients believe that running businesses is really hard. Engaging with customers is still a situation where you need to engage them and have a person in the loop. So really what they're looking for is, how do we drive this to generate revenue, or how can I provide this as a differentiator to do something that's never been done? And the interesting part is that there's probably, someone said to me the other day, there's 140 big data companies. And I think that number might actually be low. But what's very interesting is when you talk to people who run multi-billion-dollar businesses, they have very defined return on investment models. They know that for every dollar they invest, they expect X dollars in return. And what's really interesting is that many large corporations who have those investment models assume that big data is automatically going to apply to top-line growth, and they don't have to apply those models. And so the reason I put this chart in there is kind of an executive perspective for engineers who are trying to pitch to management, hey, I have a big data idea. you have to remember that your idea is being evaluated on two particular axes. The first one is most folks who come in and ask to do a big data project with our clients assume that there are legacy costs that they are replacing, meaning that if I do a massive data lake, I can retire all these old servers, I can do all these great things, I can get rid of all these applications, and look at all the money we're going to save. The problem is, over the last 5 years, many of the IT budgets have been crushed, and there actually is no replacement cost in their model going forward. So really what you're asking for is new money. And so not in the budget equals a cost increase. No matter how much you think you're saving, if they haven't allocated funds to do a big data project, you're not actually saving any money. You're increasing the cost basis. And a lot of technical folks get really frustrated with that because they don't understand the economics, and good ideas drop on the floor. The other thing is that what we're seeing a lot of big companies do is they're pitching their big data projects to their board as gap fillers. There's been a lot of economic uncertainty. Most of us are professionals, so we've invested in the stock market through our 401k. We see every day how it's going south. And so what's happening is people are filling in their long-term strategic plans with big data projects. And they're basically saying, well, we're going to now do this revenue with our big data project, and really it's there to fill a gap. And that's a real challenge for engineers who then have to get handed a project that has this kind of unrealistic expectation. So the summary on this chart is really to say, when you go forward as a technical person for your project, it would be really helpful to know if you actually have a budget for your hardware or software infrastructure, and if they're going to use your project to really be top line or to fill a gap, because those two factors really shape the expectations that are set from above. So what's driving the big data investments? I put this chart up because it really adds perspective about myth and hype. When you look at global IT spending, it is anemic at best, okay? And so you look at this flat line over the years, and it doesn't make sense because you think, how is this possible? I can't pick up a magazine or a journal and see something that doesn't say cloud or big data. And the answer is, where would we be without the hype around cloud and big data? And the answer is, we would be going negative on IT spending. So a lot of when people refer to this as being hype, what they're really saying is, we know that the market for recapitalizing infrastructure is so anemic that we need some buzzword to basically stimulate senior management to invest in IT again. And there's some actual truth to that. And that data, this chart shows you that the investment growth is so small that really it's almost for inflation. So if you look at the fact that there's no real growth in IT spending, it lends credence to those folks who believe this is just about hype, because to some degree it really is. The technology is not hype, but the hype exists so that senior level, C-level executives will then go forward and start to recapitalize their IT infrastructure. And so you have to ask is, what is this really for? So to me, you have to go back to the earlier adopters of IT. And I always call the early adopters, and I love this image on the right-hand side because I am an aerospace guy at heart. That is a Boeing plant, and that's how they used to build aircraft. All those are engineers laid out. And so IT, if you just go back for a second, coined in 1958, that it was really about acquisition, processing, storage, dissemination of all the multimedia types, which they didn't know was called multimedia, and they don't have a name for it, so we're going to call it information technology. And it was really driven by productivity, and I think the big data revolution is the same. And so the early adopters kind of were the IT old school. The early big data adopters really focused on high value productivity. So that would be in the category of things that could never be done before. So for our clients, we're building analytics that, to put it in perspective, we have a client where we built a regulatory report for. It takes us, this client has to build 200 reports, okay, and I'm sorry, to build 60 reports. It takes 5 weeks to build each report. They have to do it for 200 products, and then they have to do it in 49 countries. Okay, so 60 reports, 5 weeks, man weeks for each report, and they have to do that for 200 products, 49 countries. So when you add up all those millions of potential hours to generate regulatory compliance reports, we build that same report in about 6 seconds. So that productivity is off the charts. It's something they could have never done before. They have 750 people, and now they need 75. Now, unfortunately for them, the minute that we proved that we could do that, the regulators decided they wanted more reports. So there is a downside. Big data is very much a data lake. And so that's one of the heuristics that you have to embrace when it comes to big data, systems architecture, and engineering. So to me, the first thing is that what we've learned is a concept called data efficacy, and it's really important to big data. So data efficacy is effectively saying data has to be both valuable, and it has to be truthful, and it has to be efficiently stored, okay? And so if you view it that way, you can't just throw data together for data's sake. And you have to embrace somewhat of a free market approach to application development. Because what happens when you pull 600 databases together is that you decide that there's information that you need today because you, as an end user, wanted to see maybe a mathematical calculation that before was done by integrating 3 data sources. When that starts to get automated and they see that, they no longer need a transparent application for that. It just becomes a feature on the next application. So you really, when it comes to big data, you cannot be afraid to have a free market perishable approach to applications. And then from a project selection perspective, big data is absolutely the E in the enterprise. And so when you scope your project, and we do a lot of vetting for customers who ask us, here's our list of big data projects. And they're all truly big data from the perspective of mashing data together, and there's a lot of it. But the truth is the ROI has to be at the enterprise level. And if you can find that topic selection appropriately, you will get funding to do your project. Partner selection, this is a really big deal. With 140 big data companies in the market, people ask us all the time, how, as a consumer of big data services and analytics, how do I differentiate between company A and company B? And it's really simple. What we're seeing is we have a Fortune 50 client right now whose answer is, show me something in 6 weeks. Because if you can't do it in 6 weeks, you really can't do it. And so we're really starting to see a trend move towards rapid prototyping and the ability to deliver very quickly. In some projects, it's 12 weeks, but really 3 to 6 months. 6 months would be the longer end for a really huge project. And generally speaking, we would not see a 6-month project until they did a 6-week or 12-week pilot first. And then another point to consider is stakeholder expectations. Part of this is that you have a lot of hype, you have success stories that go out there, people want to raise the top line because the economy appears to be going in the opposite direction, and then you're fighting with a board that is used to cutting IT spending instead of increasing it. You put all those together, that's a lot of headwind for an engineer to deal with who just wants to build something. So, resource selection. When you select your analytics and you start picking folks to do the job, I will say if there's one thing you remember from this presentation, remember the number 40. It used to be 20, then it was 30, now it's 40. And when 40 is the number of Hadoop developers for every candidate that is qualified. Okay, so it's the number of Hadoop developer jobs for every candidate qualified. So put it in perspective. If you walk down to a Fortune 50 corporate IT shop and you ask them, hey, can you do this? They can download the instructions for standing up a single node Hadoop. They can download some open source analytics that are machine learning to run in Hadoop. And they can demonstrate for you in a few weeks. In our case, we give our new college hires 2 weeks to do it, to demonstrate that they can actually stand up a Hadoop instance and run an analytic. So again, our developers just out of college, just graduated, have 2 weeks to do this, and most get it done in the first week. I've talked to Fortune 50 companies who've given their IT shops 6 months, and they're proud of that. So the truth of it is, when you go to the IT shop, the fact is with so many jobs open for Hadoop developers, it has created a market imbalance. So what that means is if you go to someone internal to your company and you say, can you do this? They would be stupid to say no, because the reality is after trying it, doing it 6 months on your nickel or 12 months on your nickel, that individual is looking at a $40,000 to $80,000 a year pay raise on the market because of the job imbalance. So what that really means is when you're picking resources, you really have to be careful, because if you walk down the hall and tell someone, would you be willing to try this? And that person, because they're in IT, they know this, they know that if they have any credentials at all and any experience, that the demand for them skyrockets, they're going to say yes. And so that may not help you who's on the line to actually deliver a solution. The other thing is that for traditional non-technical companies, and we see this all the time, who have their IT shops, it's really hard for them to build a practice internally, because the salaries that they have to pay to keep those people is 30, 40, 50% higher than everybody else. And that creates some HR policy issues. It's a real problem. They don't often realize that until after they've committed to a project for the year. But they will realize it by the end of the year when their team goes to quit because they want massive pay raises. And then the other folks in the organization say, well, I wasn't given an opportunity to work on that. It happens, and we've seen it derail $25 million investments. The other thing you have to consider is make versus buy. You have cost savings for internally staffed efforts, but it's really tough because the truth is a practitioner who does this can do something in 6 weeks that would take 12 months, a team of 12 to do, because really this is still somewhat of a craft instead of a defined IT profession. And the last thing I'll say to you before moving on to the technologies is that big data is a glass bottom boat, and that's really how you have to look at it. When we integrate data sources, large, even it can be as small as like 15, 16 data sources, but when you start to integrate enterprise data, you may not like, and what you see, and anybody who's done database integration is going to tell you that you're going to see data, you're going to see results that you really don't want to see. So I'll give you an example. We integrated for a particular medical company, we integrated some data together on a device, and what we found is that when we integrated the data, they had some legacy clinical trials that was named something else. But because we can fuse and correlate data based on its content, we're able to identify these records that were not under the product name. Now, what's the problem with that? Well, the problem was the clinical trials identified issues and concerns, but it wasn't called the product that was out on the market. So what that really means is they have to pull in their lawyers and take a look and say, do we potentially have a product recall issue here? Because we didn't know this information exists, but I can tell you if a consumer got hurt during the legal process, this information would have been turned over, and it would have been clear that we knew about this, even though it wasn't called whatever the product's name was. And so it's really important to remember, and we warn every single client, every time, every engagement, when you ask us to integrate large volumes of data, we are going to find things you do not like. You must be prepared to deal with it. And so I bring that up because it's inevitable and it is going to happen. So technology. So I kind of put together, if we were going to poll people at a conference, what do you think of when you think of big data? You know, Hadoop is one. We've got some of the database components, Spark, Cassandra. Cloudera is a big player. These are all folks that either bring on the storage side or they bring the infrastructure side. But generally speaking, to give you a sense for some of them, there's many technologies out there. What I can tell you with almost certainty is nothing works as advertised. Nothing. We've worked with pretty much everything you see on this chart, plus a lot more. Nothing works as advertised. Because everybody's trying to raise capital and they're trying to sell their features and they're trying to gain market share. It's somewhat the Wild West. And so what really happens is there's a lot of advertisement and people trying to build a practice or a product around a particular client's investment. And what you should really take away from this is that when you're picking a technology, and most of the time clients, we've seen the same pattern. What they'll do is they'll say, I'm building a big data infrastructure, And so I'm going to pick some of these technologies on this chart. I'm going to create a data lake, and I'm going to do all this and then produce some application that adds value. And so then they go ask for money. They get, maybe $1 million for hardware and infrastructure and software. And then they start building the analytics, and they learn the technologies don't work as advertised, and they've probably got it in reverse order about how this should be done. So what we'll really tell everybody is before you go spend any money on trying to pick which one of these technologies works, because if you put a matrix together of features, they'll say a lot of the same thing. So when you look at that, what you should really start with is what is your data and what is it that you're trying to do. So from a technical perspective, we would recommend clients reverse the order. I can't tell you why they did it. I think it goes back to the recapitalization chart that I showed you. But typically people go buy hardware because hardware is fun. And if you go to your IT shop, they love buying hardware. Our IT folks love buying hardware. So everybody wants to buy hardware, and then they want to put some software and then figure out what they're going to go do with it. The problem with that is analytics, if you know what you're doing, depending upon the type, and I probably should have clarified that we consider big data a topical category, but if you really segregate it, big data is somewhat unstructured text, and large object data, which is a part of big data, is really what we refer to as video and imagery. So it doesn't really matter which one you're picking. The point of it is that depending upon which one you're picking and what you're trying to do, you can expand the source data by 1,000x, and that's if you're good. In our early days of building analytics, I would say as we bring people in and they're trying to understand what can you do with MapReduce or what can you do in memory, the expansion is significantly more. It could be 5,000x. So what does that mean? Well, it impacts memory, RAM, storage, and all those things that cost a lot of money. And so what happens is when they define the physical architecture first and then the analytics, in every single client case that we have, they've had to scrap the hardware. In fact, we went through an exercise recently with a client who has 12 facilities, and each physical instantiation is about a $5 million investment. And what happened was when they started looking at the analytics and to finalize what they needed, they realized they overcapitalized by 75%. So basically, they spent about $40 million, $45 million more on hardware than they needed. And the hardware they have isn't optimal for the analytics they build. This happens all the time. And so if you're a developer of big data, what you really want to try to do is advocate for your analytics, trial with real data, figure out what the expansion is, and then work with IT to define the physical infrastructure. The other thing I'll say is that you meet a lot of folks who said, I tried this, I did this, I touched this. And I will tell you, we are as guilty as anybody else. We see a technology that we touched 18, 24 months ago. And the reality is, given the amount of money that the big data companies and infrastructure companies are raising to the tune of hundreds of millions of dollars, the technologies are maturing incredibly fast. But there's a problem with that. They're moving so fast and adding so many features that often they're not backwards compatible. And so we just went through this recently with a large project where the clients are constantly chasing the latest release. And unfortunately for the client, they migrated to a particular recipe, what I'll call, of components, and that recipe was not backward compatible, and then they had to go redo all of their analytics. So I bring that up to point out that with the massive investments, with the massive expansion, what happens is you have to be careful. Jumping to the latest release of these components, and there could be 70 of them in an infrastructure, may not be good. There's a massive demand for resources in this field. I showed you the number 40, which means that combined with a younger workforce who likes to move and jump and move around, it means that if you're going to go down a big data science project, you have to treat it as if it is a no-kidding commercial release, because the amount of documentation and code quality that you have to have, the level of code quality you have to have, is somewhat analogous to what you would expect for a no-kidding enterprise-wide retail commercial product. It puts a lot of stress on the developers, it puts a lot of stress on the technical management team, but you have to have a very sophisticated, very mature product development process in order to build these products. Another point that I will mention is that it's really important to have abstraction layers. And so this is probably the most important part. When you build data lakes, what we really try to do, and it doesn't have to be a data lake, but any kind of massive aggregation of data, that you really have to separate the data layer from the application, and in some cases from the database, the storage layer themselves. And so if you decouple these services and your applications in the storage layer, it becomes really important, not just from an abstraction architectural perspective, but the service and the maintaining of those components is orders of magnitude easier. And so these are some of the technical issues that we deal with on a regular basis. I will say the link that's in this slide, that one right there for Hadoop ecosystem table, GitHub.io. I recommend anybody who's interested go there. It has an expansive list of big data technologies, and it's one of the starting points that we would give one of our developers who's starting out and say familiarize yourself with these technologies. So some things to think about going forward, and I bring this up. I love our employees that are just coming out of college. They've got a lot of energy, incredible amount of talent. But one of the things I tell senior executives all the time when they talk about big data projects, younger employees view the digital corporate infrastructure the same way that older employees view the physical infrastructure. And I bring this up because I was at a major cancer research institute, and they had asked us, how do we integrate genomes into a cloud environment so that we can genome match? So we were doing some genome matching on viral and bacterial data, and so the cancer folks came to us and said, can you help us figure out how we are going to match profiles, individual profiles with genomes with treatments? And then, so it's really novel. It was really a great idea and it's a great project. And one of the scientists said to us, I don't have a wiki. So if I don't have a place I can collaborate, and I don't have the ability to create my own virtual machine, now this is a researcher, if we can't do that internally, how are we ever going to cure cancer? And so I bring that up to say that even though we were in a building that you could eat off the floor, and it was spectacular, it was beautiful, and it was the envy of most corporate America office buildings, that to the researchers, they were really looking at the technology infrastructure, the IT infrastructure, and then trying to make a decision on what can and cannot be done based on that. So we tell a lot of clients, you know, despite all the fears and concerns, you may not have a choice. You really have to migrate down this path, and you have to do it smartly and show some value, because if you're solving really hard problems, it's hard to imagine solving a difficult problem without a big data element or a big data layer. The other point I'll make is that we continue to see in the first and second generation implementation of big data, they really focus on excuse me, some productivity improvement or cost savings or capabilities that cannot be done any other way. So right, they're doing this because they are either some massive revenue generation that comes out of a productivity improvement, cost savings capabilities. There's some initial reason in those first, second gen. Excuse me. The later generations are really when you see revenue. So the initial ones, they talk about generating revenue, but you really don't figure it out until that third or fourth cycle. And that's important because we really, I'm sure someone out there has done it, but for most of our clients, they entered it with a thought of monetization, but it took at least 2 or 3 design cycles before they were able to pinpoint what that monetization would be. The other thing I'll say, and I kind of alluded to this earlier, is that as someone who has a lot of developers, they don't really care about something called data governance, right? And so in data governance, sorry about that, I think I got it out of my slide. In data governance, you have to make sure that the person has access to the data. And so that's really important, because when you start building these aggregated data centers, if you don't have access to the data, then you can't aggregate it. And so what we try to tell our clients if they're trying to go down a big data path is start with governance, start with analytics. So analytics and governance have a symbiotic relationship. I can build analytics that do great things, but if I cannot come up with rules about who can get the data, who can access the data, and how we use that data, if I don't resolve that, then there is no technical project. And so it's amazing to me because we go through this on a regular basis, mostly with our commercial clients, who often want to aggregate customer data. And so customer is a pretty nebulous term. We dealt with a particular medical insurer, and their definition when they aggregated all the customer data, it was interesting. One's customer database was actually the Securities Exchange Commission, another was the medical regulators, another actually meant consumers. And so when they started aggregating all this data, regulatory issues come into place. And so you can build the analytics to show it's possible, but if you don't have a data governance person with you, it's really tough to make a case to move the project forward. So it's funny that one of these non-technical issues becomes technical because one of the great things about big data is that you can protect data at the statement level, at the instance data level. So what that means is I can put in particular restrictions that are dealing with personal identifiable information, and I can do that inside a huge, massive aggregated data layer. But I have to have a corresponding security layer that goes with it. So what's really happening for big data people, which is why I say it's more the professional services side, is that it's really important to not just have your computer science folks, but you have to have enterprise architects, you have to have security people, you have to have folks who understand enterprise architecture in order to actually implement the simplest of big data programs. And then the last thing I'll leave you with is that, however discouraging, but in our travels, what we found is that large object data may actually be what redefines the IT market. And so the reason I bring that up is that the work that we've done in genomics or video or imagery, those are not really what Hadoop Big Data was built for. It wasn't what it was originally there for. But what's really interesting is that it's really challenging folks on our traditional mental models. So for example, obviously you know that you can hold up an image. And we have some really great analytics where we can do non-cooperative, which means we can look at a crowd, you can pull up a video camera on your phone, scan the crowd, and identify who's in that crowd. And so that's really cool and it's really great. But as an individual, doesn't that violate my personal privacy? I don't want someone else to know who I am, and I'm not comfortable sharing that information, and how did they get it? So it's somewhat challenging. The other thing is we had a case with a particular casino who called us in and said, we have all this data, can we process it? And the answer was yes, it was great. And the problem with that was they said, geez, you know, if we're in our facility and you can tell us with some pretty darn good accuracy whether the person who walked through the door has committed a felon or not, or is wanted, that's great. And they thought that was wonderful until the lawyer stepped in and said, you do know we'll be arresting people because we have a high volume. It could be a theme park. It could be any place with a high volume of average consumers. And so a mall, any place like that. Well, the problem with that is if you can identify them against criminal lists and the police are coming every single day, well, that's going to be on the police blotter, which means they're going to continue to say, hey, at the mall or at Disneyland or wherever it is, they continue to arrest criminals who show up. So as an average consumer, you're not going to go. And so these kinds of issues challenge the legal liability, saying, well, now that we know we can get it, do we have to do it? And now that we know that it can be done, is it something we should do? The other thing I will say is that it is probably more widely known on the genome is another example. We've gotten to the point now where we can use the genome, we can run the analytics to do a prediction to say, are you more likely to have certain conditions? And so if you knew, would you run the test if it told you you were 90% likely to have Alzheimer's? Is that something you want to know? Some people yes, some people no. So what I would really say is that big data is not hype. We have customers who are doing things they could never do before. Massive cost savings, massive productivity improvements. But what's really going to happen is as it migrates away from a traditional text-centric base and moves into other mediums like video and genomics and imagery, it's going to challenge the way we view technology. And we really believe this. And I think those challenges make us question how far should we take the technology, because it's a non-technical issue. And then you kind of saw this chart. We're big data evangelists, so my sense is if you're going to pitch a project, if you're going to go into a crowd that has read all the myths, all of the things, the truths, and decided that they are for or against your initiative, go big or go home. You pick a project that is wonderful, embrace, take in the lessons learned, understand that this is really hard and difficult work to do, and address every one of those technical issues as you work through it. So I ran through those fairly quickly, and I wanted to leave some time for any questions. And so with that, I guess I'll turn it over to Jamie. You can moderate if you want, or if anybody has any questions, feel free to ask me. But thank you.
I have unmuted the participants, and one could ask a question orally or one could use the chat function. Any questions for Brian? I'm not seeing any come through on the chat. I've brought up on the screen where we archive the Hawk Talk Professional Development Series on the alumni website. And as you can see, we've built a nice little inventory, and I would encourage you to peruse these. Some are by alumni, all are by industry experts, and would encourage you to take some time. I see that JMM has said great presentation. Thanks for taking the time. And thank you, JMM, for participating today. I don't see any other chats coming through. I encourage you to ask your question now, or we're going to go ahead and end this session.
Thank you, everyone, for participating. And again, if anybody has any questions past this, feel free to reach out to me as well. And I'm happy to answer any other. I know it's kind of sometimes a little bit programmatic or business centric. If you have specific technical questions, feel free to ask them. If I can't answer them directly, I promise you I will get someone who can. So if you have any of those, feel free to ask as well.
Well, thank you all for joining this session, and Brian, thank you on behalf of your alma mater for taking your time today to help lend some insight on big data.
Thank you.